Welcome everyone to the October meetup. Yes, there's a bunch of stuff going on, but Damien's going to talk a little bit about one of his projects that he's talked about lightly in the past, but I think he's going to go into a few more details. And I've got a little bit of a news roundup to give, so follow him on that. So thanks, Damien.
It's all right. Okay, I'll share my screen in a second. What's the lighting like? Okay. Hello, everyone. Well, I did talk a little bit about this quite a few meetups ago. I was working on a E Ink weather display. It's working now. I can show you what it looks like. This is that inverted? No, that comes through.
Yeah, that's good.
Yeah, hang on, I just got to get rid of this message. Yep. So you can see it's in a nice 3D printed enclosure as well, and it says the current weather is currently very stormy and windy.
Possible shower, hey?
Possible showers, yeah. No, there was a lot of showers today, or storm. And then on the back, it's a very simple setup. It's got a battery, and this thing is the display adapter. So there's a flexible connector going into that from the E Ink. And then there's a Pi board D here with underneath it just a little adapter to plug it into the screen, and it also has a temperature and humidity sensor on the back there. This is actually it's just blue tacked in, but yeah, so underneath here there's a sensor and plug it into the battery. So it's pretty simple, but it works really well. So it's been sitting on our kitchen wall for about a month now. It updates once every hour, or it depends what the time of day is. So in the morning, when we want to know precisely the temperature, and the temperature is sort of increasing rapidly, it updates every 15 minutes. In the evening as well, when it's cooling down quickly and we're running around for dinner, it cools down. It updates every 15 minutes. During the night, it updates every 2 hours because no one's around really to see it. And during the day, otherwise, about every hour. And the battery, I reckon, would last about a year with this doing that, because at the moment it's literally just off. Well, the microcontroller is in deep sleep mode, drawing about 20 microamps. The battery is 2,000 milliamp hours. So most of the time it's sitting there doing almost nothing and drawing very little power. To update the display, it turns on. It connects to the Wi-Fi. It does an NTP time update to get the current time. It doesn't yet update the time zone. So when we had daylight savings a few weeks ago, it was wrong, but that's okay. That's a tricky problem to solve. And once it's updated the time, it then logs into the BOM to an FTP site, downloads the forecast, and then logs into another site to download the current temperature and wind speed and humidity. And then once it has all that data, it saves it to its file system, and then it renders it to the screen. The screen update takes about a second, and I can do that now. So you'll see it update in about maybe 10 seconds. But once it's updated, it then goes back. It works out how long it should sleep for until the next wake up, depending on the time of day, and then it goes to sleep. It's going to update in a couple of seconds. You'll see it flicker black. And then, so that did an update then. So you can force an update just by resetting it, but otherwise it will update automatically. So it's pretty useful. And my one requirement for this device was that it used the Bureau of Meteorology data, because that's way more accurate than the other websites. Now, of course, this is nothing unique or new. Lots of people have made E Ink displays with weather, but as I said, my requirement was for the Bureau of Meteorology, which I couldn't really find any existing solutions. I also wanted to write it in MicroPython, of course. And it was a lot of fun doing it. It's a lot of fun building stuff. And then I actually bought a 3D printer so I could print this case and do a lot of other things. But that was also fun. Learning how to model this. It was actually modeled in FreeCAD, but it's very simple. It's just like a box subtracting another box, and then you print it. So yeah, it was really cool and it works really well. I can show you a little bit of the code. What I actually do, because it's Python, I can develop in the Unix version of MicroPython, and then once I have it all working, I can deploy it to the device. So you can easily develop on the device, but you can also very easily, much more easily, develop on the PC. So if I just share my screen, so I have a mock version of it which runs on the Unix port of MicroPython, and to get the mock thing working, you just have to sort of, well, you can fake the date time or get the current date time on your computer. You can load like test set of weather data. So I have some existing JSON and XML data from the BOM, which I've downloaded to test different, visuals. And then obviously you mock the room temperature and the humidity and the current battery level, because the PC doesn't have a battery that's relevant here. And then create a fake device, because I don't have an E Ink here. It's just a frame buffer. And then the render function here is the one that would run on the device. So you're passing it in the current time, the weather data, the battery data, and the frame buffer, which it will render it to. And then you can write the result out to a file to view. So if I run this, so it just did all of the rendering then and loading of the data, and then created an output PNG, which looks like what you saw on the device. So this is exactly what the code would run on the device. So it's the exact same pixel for pixel output with the same resolution. So it's very easy to prototype and change things around, change the fonts, change the layout. So at the moment we've got a forecast for 4 things: Thursday, Friday, Saturday, Sunday. So say I wanted to change the forecast. So the weather, so the weekly forecast. So I've got there's a data structure here with the weekly forecast. So let's just do it. Let's subtract 1 from that forecast, and then run the mock and look at the output. So now we only have 3 days forecast here. So you can see it's very, very quick and easy to change the layout and update things. And then if things go wrong, for example, if we, I think, make it a little bit too big, yeah, you get your layout goes all funny because of the way it renders fonts. So it's not easy to lay these things out and also make it look nice. But in this actual display here, I think there's 8 fonts that I'm using here. There's large font for the icons, small font for the icons. Then there's giant font for the current temperature, slightly smaller font for the other things you see here, and then a small font for the humidity and pressure, and then a really tiny font down the bottom for the upcoming rain. And actually, no, there's a 9th one, which is this one in the bottom right corner for the battery percentage in the last update. So there's a lot of stuff going on there, and the fonts that are used are just TrueType fonts that you can just download any TrueType font on your PC, or any free TTF file you could find. And then Peter Hinch has written a really good conversion program which loads a TTF font and then converts that to a Python file which MicroPython can use. So it's a set of bitmaps, and when you render text, it just loads the right bitmap for the current character and blitz it to the frame buffer. So that's what this is using. So that's been very, very useful. There's actually, the whole thing here is really just text. There's no lines or anything. The icons for the weather come from a free icon weather font, and that's a font as well. And you can scale that up and render it whatever size you like. So it's all just done with fonts and drawing text in the right location. I think that's all I wanted to say. Of course, there's a lot more I wanted to do with this. And Matt showed me terminal with no vowels, TRML, which is kind of almost exactly the same thing. The product looks very, very similar. It has the same kind of form factor. It uses the same screen as far as I can tell, literally the same E Ink display. And the way that works is that most of the processing is done on a back-end server, and then it pushes to the display the image that it wants to show. So the actual display doesn't do much processing. It just has to wake up, connect to the local network, connect to its server, and then say, what do you want me to show? And then disconnect. Whereas in this case here, all the smarts run on the display, and it's completely standalone, well, apart from needing the internet. So, but like I would like to also make picture frame displays with a color E Ink would be great, and just show rotating pictures. But in order to do that, you'd need to either store the pictures on the device or have a server that had them, and then it would have to retrieve them. That'd probably be a better way to do it, because then you can update them without having to, take the device off the wall and plug it in and copy new files across. So that's my future plans for this. But currently, this weather display is very useful in the morning to know what the temperature is going to be, what you should wear. And it uses, lots of little bits of MicroPython. I think the thing that it shows me about MicroPython usage, so when I'm developing MicroPython, there's lots and lots of things that go into it. Like it can do Wi-Fi and Bluetooth and Ethernet and USB and I2C and SPI and ADC, and you can plug in lots of sensors, and there's so many parts to MicroPython. But when you're actually making a project, you only use a very small subset of the things it can do, of the features that you have at hand. So here, all we need to do is connect to the internet and download something and then write it to a screen. So we're not using a lot of what MicroPython can do. And I think most projects, well, a lot of projects would be like this, that you only use a subset, but it's a different subset, of course, each time. But yeah, being able to mock and use the same code on your PC to develop, I think, is very fast. And I know lots of people do things that way. It's beneficial. So if you structure your project so it's made of components so that you can test them independently, that's the best way, I think, to go about it. I was also actually using a ROMFS, which is sort of a very new feature, but to store all the fonts, there was about, I think it's about 600, 700K of font data, which is stored as one big ROMFS. And that's actually mocked as well onto the PC. The PC actually loads that ROMFS as well. So it's the same. It's all the same data that's used locally and remotely. So yeah, happy to take any questions about it. I haven't yet published the code, but I intend to, and then you can have a look at how it works. I see there are some questions. Oh yeah, which microcontroller? Yes, the Stuart was correct. It's a STM32 F767. It's pretty overpowered. I just had a bunch of them, a bunch of them that don't work in some way or another, that were half broken, that I could reuse for this project. So yeah, this one here. I think this one doesn't have an SD card because it was not working. But I think you could use a RPi Pico W for this. It really doesn't need any processing power. I clocked this microcontroller down to like 48 megahertz, like a quarter of its normal speed, but just to get lower power consumption, and it just doesn't need to run fast. But although we did need a bit of storage for the fonts, they take up a lot of the room. Yeah, the display, it's just an SPI display. There's more than just the e-paper driver that I had to write. There was the vendor Good Display. They have some. It's like two Ds overlaid, so it's actually Goo Display, but it's a double D. It's like good. It's weird, and they have some Arduino driver code to sort of, because it's sort of the best documentation on how to make the display work, and I converted that to MicroPython, and it worked just fine. It has a SPI bus, a DC, a CS, busy, and reset line. So 1, 2, 3, 4, 5, 6, 7, 8 lines. It's not that complicated, and it doesn't have to be fast. So definitely you could do that on a Pico. There's a temperature sensor and humidity sensor, which is connected over I2C, and the battery and a battery charger. And then a sort of a voltage divider to measure the battery voltage. But the hardware is pretty simple. Schematic. So the schematics are not really written down anywhere. It was just like, I'll solder things together until it works, sort of thing. The only thing, because this display board here that you just get from Good Display, it just has there's an 8-pin bus here. Yep. And I'm just like, well, I'll just wire those up to certain pins. That doesn't really matter which pins, as long as the power is correct, everything will work. So that's really all it is. I didn't write a schematic for this. It's really just wiring the display to the microcontroller. Because underneath, I can actually take this off. Underneath the microcontroller is just this adapter board, which is a stock part. So, and that just has that header connected to it. It just so happened that I could connect it directly here, and it worked. There was really nothing to the schematics. But yeah, the code I will put online, because I think it's a nice example of how things work. I just had to clean up some of the JSON and XML parsing, which I wanted to put upstream, but perfect is probably going to be the enemy of good in this case. Anyway.
That looks like a good project.
Yes, it is fun doing projects. I think I've said this many times before, but MicroPython is a combination of hardware and software, and I think that's what makes it fun and interesting. And at least for me, it's not just a software project, and it's not just a hardware project. Yeah. So, yeah, really cool to have both those, be it the fusion or the boundary of those two things.